Okay, so if I jump ahead to the last few examples on our handout for today, you might see, or might start to see more of the benefit of using our half angle formulas, or, you could probably understand where the double angle formulas would come into play as well. In number 19, we're being asked to find the exact value of sine of 22.5 degrees. And we never did memorize that on our unit circle. Um, but what's interesting is that 22.5 degrees is exactly half of 45 degrees. And we did memorize the sine and cosine values at exactly 45 degrees. So by using this half angle identity, we could probably figure out the precise result for sine of 22.5 degrees. We don't need a calculator to do so. So as a reminder, the half angle identity for sine says that um, we need a positive and negative square root of 1 minus cosine of alpha. And now alpha is twice the size of this. Remember, this guy right here is alpha divided by 2. We're picturing that as alpha divided by 2. We're going to divide this by 2. So in this particular case, we'll go ahead and take 1 minus cosine of 45 degrees. Now, we can pretty easily eliminate this plus or minus symbol if we consider where the position of this particular angle is. Now, sine of 22.5 degrees, 22.5 is somewhere down here. The result when we're done, the y value at this position is positive. So I don't need to even consider this negative component anymore. I know that when I'm finished, I'll be dealing with a positive result. So from here on out, I'm not going to include that anymore. Now, 1 minus cosine of 45, the x value at 45 degrees is square root 2 over 2. And if I were willing to give it a try, if you encounter this question on Math Excel, I might try entering this into Math Excel because it is an exact answer. Um, it's precisely what they would be looking for. There's no decimals or anything like that. It's just not in the most simplified or reduced form. In fact, I think the instructions on Math Excel tell you to take this a little bit farther. So what they would suggest is that you consider the number 1. The whole number 1 is the fraction 2 over 2. 2 divided by 2 is equal to 1. And if you consider this as 2 over 2, then you can combine the numerator into a single fraction. So let's go ahead and write that here. 2 over 2 minus the square root of 2 over 2. Well, that would be 2 minus square root of 2 over 2. And all of that is written over the fraction 2. And when this numerator's denominator is being divided by 2, it's kind of a weird way to think about all of this. We're now looking at, I'm going to give myself a little bit of extra space here, 2 minus square root 2 over 4. And so this is kind of interesting in that we've got the nested radical signs here, but this is the most precise answer for the y value at 22.5 degrees. And if you're second guessing yourself, let's go to the calculator and figure this out. Sine of 22.5 degrees is going to be some decimal value. And using a basic calculator, we can figure that out. 22.5 degrees, we're in degree mode, so I'll press sine of that. So sine of 22.5 degrees is 0.38. So sine of 22.5 is 0.38. If I punch this fraction, this one down here, this square root of 2 minus square root of 2 over 4, into my TI calculator, let's see what that's going to end up as. So we've got a square root, a fraction on the inside, and we want in the numerator 2 minus square root 2 and all of this over 4. And if I look for the decimal equivalent there, we got 0.38 as well. And again, if we compare the answers, here's our result for sine of 22.5 degrees, and here's our result for that fraction simplified. And we've now determined that those two are the same. You may be looking at my calculator and you'll notice that my calculator here, this TI calculator, is in radian mode, and that's okay because I didn't use a trig equation in this expression. We're just evaluating numbers at this point. And that's really, really important because we're noting that this, I don't know if you want to call it a shortcut, but this process that we've shown here gives us a way to evaluate the trigonometric result without the use of a calculator, without the use of a trig expression in the calculator. In a way, it gives us a method for evaluating this trigonometric result using a more simple calculator. So I thought that was pretty interesting and pertinent for our work here today. For number 20, we would do much the same. And if we're considering this argument, 22.5 degrees is some alpha divided by 2, then the alpha value truly is 45 degrees. And we can again evaluate cosine at 45 degrees. One more time, if we think about the position, 22.5 degrees being over here somewhere, this coordinate is definitely in the first quadrant, so the x value, the cosine result, must be positive. And again, I'll throw out this negative potential and simplify from here. I'll let you do that on your own. And I'll do one more example here, this number 21. After we complete 21, it should be pretty similar to 22 here. In 21, we're saying that alpha divided by 2 is equal to 7 pi over 8. So if alpha divided by 2, let me write it this way, alpha divided by 2 is equal to 7 pi over 8, equal to 7 pi over 8. Then if we multiply both sides by 2, we'll see that alpha itself is equal to 7 pi over 4. And this is a value that we understand from inside of our unit circle, and we'll be able to utilize that with the half angle identity. Now, tangent is equal to either the positive or negative 1 minus cosine of alpha, which we're saying is 7 pi over 4, and 1 plus the cosine of alpha. I just realized that I didn't hit the record button, so I'm not quite sure where I left off, but I'll summarize what I've done here. The positive potential solution has been thrown out at this point. Remember, because we are talking about 7 pi over 8 in our original angle. 7 pi over 8 exists in this second quadrant, and tangent must be negative in that position, so we threw that out. Secondly, I started thinking about cosine of 7 pi over 4 to help simplify our solution. And 7 pi over 4 is the position right here. It's the last 45-degree angle before horizontal. And in this position, x is positive. So if I need to simplify this, 1 minus the x value, which happens to be the square root of 2 over 2. So we've got 1 minus square root 2 over 2 over 1 plus square root 2 over 2. And if I were going to make a guess, I would think that Math Excel will accept this. As long as your work is done correctly and your answer is precise and correct, it usually will accept it. I haven't tried this recently, so I don't know for certain on this particular example, but I'm fairly sure that they would. Oops, but we need to include the negative sign out front here. This is a negative sign that's supposed to carry down. I think if you use the help me solve this or show me an example, they will ask you to find a common denominator, perhaps even rationalize the denominator, and ultimately simplify to something that looks like this. I think it'll end up being negative square root of 3 minus 2 square root of 2. And I don't know how much more simple that is than this one. I mean, clearly there isn't a fraction there, but the amount of work that goes into this, we're talking maybe 2 or 3 lines worth of work to get to this position, it may not be worth it. So I would suggest trying this solution in Math Excel. If it doesn't accept it, then read the help me solve this or show me an example offerings, and pay close attention to see what algebra they use to simplify from there. Hope this video helps. If you've got additional questions, please let me know. Send me an email or a message through Schoology, and I will talk to you later. Thanks.